Good morning. Okay, so today we're going to be covering operations of functions. This is simply the sum, difference, product, and quotient of two or more functions put together. So we have a couple rules that dictate how this works for each of these different operations. So, for sum, which is addition, hopefully we all know that, if I am taking the sum of two functions, so f plus g of x, this is the same as taking the function solved at x plus the second function solved at x and adding their answers together. If I'm taking the difference of two functions, hopefully we know that the difference is subtraction. The same system works. So if I'm doing f minus g of x, this is the same as my first function solved at x minus my second function solved at x. And x here could also be a number, so we could be solving at a specific x value. We also have the product, which hopefully you recognize as multiplication. If I am doing f times g of x, this is the same as my first function solved at x times my second function solved at x. So again, we break it apart, solve each one individually, and then multiply our answers. The same thing also applies to the quotient of two functions. Quotient here is division. And if I have f divided by g of x, this is the same as my numerator solved at x divided by my denominator solved at x. There is a stipulation though with g of x. What can it not be equal to? Hopefully you recognize that it cannot be equal to 0, because if it is, then that is undefined and would not give us an answer. So these are the rules that we're going to follow when we're talking about operations of functions. Let's go ahead and do a couple examples with actual functions and simplify them out. Okay, so I have two functions. The first one is f of x, which is equal to 3x minus 2, and g of x, which is equal to x cubed. I would like to find 4 functions that contain operations. So the first one I would like to find is f plus g of x. If you look back at your rules, this is simply saying that I take my first function, solved at x, plus my second function, solved at x, and I simplify it out. What's the only way I can simplify addition? Well, combine like terms. There's nothing here I can put together. So my addition function is simply x cubed plus 3x minus 2. And that's it. Let's go ahead and try the subtraction version of this. Again, this is the same as the first function solved at x minus the second function solved at x. My first function is f, so I do 3x minus 2, minus my second function, which is g, which is x cubed. Just like before, the only way to simplify subtraction is to combine like terms. There's nothing I can put together, but I can reorder this in standard form. So I end up with negative x cubed plus 3x minus 2. It's a negative x cubed because this was subtraction right here. And I would also like to find the product of these two functions. So what I do is I go ahead, I take my first function, which is 3x minus 2, times my second function, which is x cubed. I need to distribute this. So I get 3x to the 4th, because I add exponents when I multiply, minus 2x cubed. Nothing else I can do from there. So what if I wanted to take this one step further, and I wanted to plug in x equals 2? Well, I'm going to take this final answer, and I'm going to plug 2 in for x. So f of g solved at 2 is going to be 3 times 2 to the 4th minus 2 times 2 cubed. I go ahead and I can simplify this out. 2 to the 4th is going to be 16 times 3 is 48 minus 2 cubed is 8 times 2 is 16. I get 48 minus 16, and that's going to equal 32. Another way I could have done this if I had started out with f times g of 2 is I could have taken 2, plugged it into each of those functions, gotten their answer, and then multiplied their answers together. For instance, if I had done f times g of 2 from the very beginning, I would have done, okay, 3 times 2 is 6, minus 2 is 4, times, so this would be the same as f times g. 2 plugged into f gave me 4. 2 plugged into g gave me 2 cubed, which is 8. 4 times 8 equals 32. So they both come out to the same answer. It just depends on what you're starting with. So let's go ahead and do f divided by g of 2. So again, our two options are to leave it as x until it's simplified and then plug 2 in, or to plug 2 in from the start. I'm going to go ahead and do it both ways because I think that's just kind of fun. So my f function is 3x minus 2 over my g function, which is x cubed. Well, I can't do anything from here because there's nothing I can simplify. So I would go ahead and plug 2 in, and I get 6 minus 2 over 8. 6 minus 2 is 4. Divided by 8 simplifies to 1/2. Let's see what would happen if I plugged 2 in from the start. So f divided by g of 2 is the same as the function solved at 2 over the g function solved at 2. 3 times 2 is 6, minus 2 is 4. 2 cubed is 8, which reduces to 1/2. So it is entirely your choice which direction you would like to go with this. Let's go ahead and do another example. We're going to say f of x is equal to the square root of 4 minus x squared. And g of x is equal to 3x plus 1. I'd like to start by finding f plus g of x, so the addition of these two functions. I know it looks a lot scarier because there's a radical in there, but it doesn't change the way I process this. So I'm still going to take my f function with x plugged into it, plus my g function with x plugged into it, and I'm going to combine like terms. There's nothing here that I can combine, so it just stays 4 minus x squared plus 3x plus 1. So what if I wanted to take this one step further? Let's say I wanted to find the domain of this function. Okay, so domain, remember, are all possible x values that could be plugged in and solved with. Okay, so as before, sometimes it's easier to find the numbers that don't work rather than the numbers that do work. So is there any part of this function that would have a limitation on the x values that could be plugged into it? Well, yeah. That 4 minus x squared right here is under a radical. So I know that whatever answer I get when I plug in x, it cannot be negative. So I need to take that 4 minus x squared, and I need to set it so it's greater than or equal to 0, and I need to solve for x. First thing I'm going to do is subtract the 4 across. So I get negative x squared greater than or equal to negative 4. Divide each side by a negative 1, which means I need to flip the sign. And then I need to split it by taking the square root. So I get x is less than or equal to positive or negative 2. If I use the negative version, of course, which means x is less than or equal to 2, and x is greater than or equal to negative 2. So then my domain is going to be negative 2 less than or equal to x less than or equal to 2. You can check it by picking a number that exists outside of that domain, for instance 3. If I plug 3 in for x, 3 squared is 9, 4 minus 9 is a negative 5. I can't take the square root of a negative 5, so that number can't possibly exist in my domain. So the only numbers that do work are these numbers. Okay, so now I'm going to go ahead and we're going to do another operation, and we're going to do f minus g on this one. Same as before, I take my f function with x plugged into it, minus my g function with x in it. Simplify it out by just distributing that negative. And I get the square root of 4 minus x squared minus 3x minus 1. Just like before, I'd like to identify my domain. I already know that it's probably going to be the same as my addition domain was because my radical didn't change, and it's still the only exception I can have for x values. So again, my domain is going to run only from negative 2 to positive 2. You could also write this as an interval if that's what you wanted to do. Let's go ahead and do a product then. So f times g of x. This is going to be the square root of 4 minus x squared times 3x plus 1 There honestly isn't a whole lot that I can do with this one. So I'm actually going to leave it unsimplified. If you had wanted to simplify it, it would have turned into 3x times 4 minus x squared plus 4 minus x squared, which is really not too pretty to look at. But I can still find my domain from here, correct? Well, what do I notice about my domain? Is it going to be any different than the previous problems? No, because my radical hasn't changed. Okay, and I don't have anything else that would be an exception to my domain values. So my domain still runs negative 2 to positive 2. What would happen then when I did a division? So this would be radical 4 minus x squared over 3x plus 1. I can't simplify it, so it stays like this. I already know that the domain of my numerator exists only between negative 2 and positive 2. But what do I know about my denominator as well? What can it never equal? It can never equal 0. So if it does, I would get an undefined function, which means it could not possibly be a part of my domain for that x value. So I need to solve for that x, and when I do, I get negative 1/3. So my domain still runs from negative 2 to positive 2, but I now need to exclude negative 1/3 because that can't possibly be plugged into my function. I know I had to exclude it because it exists between negative 2 and positive 2. It is closer to 0 than negative 2 is. So after operations of functions, we also do composition of functions. This is a little bit different because it is plugging one function into the other function and solving it that way, not just multiplying them together. So we look at this as f of g of x, which is the same thing as taking that outside function f and plugging the inside function g into it. F is not always going to be that outside function. It's just whatever is listed first is the function that's being plugged into. Whatever is listed second is the function that is being plugged into something else.